Welcome to Pioneer Career. Now today we are going to discuss divisibility test. So to start with, divisibility test of 2, 4, 8, 16. Divisibility test of 2. If last digit of a number is divisible by 2, then number is also divisible by 2. In other words, if last digit is even number, then that number must be divisible by 2. 4. If last two digit of any number is divisible by 4, then number is also divisible by 4. Just take an example. 72524. This number is divisible by 4 because last two digit 24 is divisible by 4. It doesn't matter what you write down before this. The number is always divisible by 4 because last two digit 24 is divisible by 4. Now for 8. If last three digit of any number divisible by 8, then that number must be divisible by 8. Just take another example. 7824. Since last three digit of this number 824 is divisible by 8, hence this number is also divisible by 8. Again, it doesn't matter what you write down before this. The number is always divisible by 8 because last three digit is divisible by 8. Similarly for 16, if last four digit is divisible by 16, the number is also divisible by 16. Just have another look on another aspect of this same theory. Since 2 is equal to 2 to the power 1, hence we are checking last one digit. 4 is equal to 2 to the power 2, hence last two digits. 8 is equal to 2 to the power 3, hence last three digits. 16 is equal to 2 to the power 4, hence last four digits. What does it mean? For 32, we'll check last 5 digit because 32 is equal to 2 to the power 5. Similarly, 64 is equal to 2 to the power 6, so we'll check last 6 digit for the divisibility test of 64. Now, what is the reason behind this last 2 digit and last 3 digit? Just take an example. 1724. This number is divisible by 4 because last 2 digit is divisible by 4. But what is the reason behind this? This number we can also write down as 17 into 100 plus 24. Now whether you write down 17 or 27 doesn't matter. This portion is always divisible by 4 because 100 is divisible by 4. Hence remainder is governed by last two digit. Similarly, if you check the divisibility of 8, then this same number we can write down 1 into 1000 plus 724. Whether you write down 1 or 11 or 111 doesn't matter. This portion is always divisible by 8 because 1000 is divisible by 8. Hence remainder is governed by last three digit only. The same concept is applied for 5 and 5 powers of 5 as well. For 5 we check again. 5 to the power 1 is equal to 5. Hence divisibility test of 5 is last digit. If last digit of a number is 0 or 5, then number is divisible by 5. 25 is equal to 5 square. Hence if last two digit is divisible by 25, then number is also divisible by 25. 5 cube is equal to 125. So if last three digit of any number is divisible by 125, then number is also divisible by 125. Now we'll see the divisibility of another numbers. Divisibility of 3. If sum of digits is divisible by 3, then number is also divisible by 3. Just take an example. 123. Sum of the digits is 1 plus 2 plus 3 is equal to 6. It is divisible by 3, hence number is also divisible by 3. The same rule is for 9 as well. Sum of digits. If sum of digits is divisible by 9, then number is also divisible by 9. Just take one example, rather one bigger example. 7, 8, 6, 5, 8, 6, 9, 5. Whether this number is divisible by 9 or not. So we will find the summation of the digits. If summation is divisible by 9, then number is also divisible by 9. So summation of digit is 7 plus 8 15 plus 6 21 plus 5 26 plus 8 34 plus 6 40 plus 9 49 plus 5 54. So summation of the digits is equal to 54. Since 54 is divisible by 9, hence this number is also divisible by 9. The same summation we can do in other way also. 7 plus 8, 15. So once you got a 2-digit number, make it a single digit number. Add the digits and make it a single digit number. So 7 plus 8 equal to 15. 15 we can write down as 1 plus 5, 6. Then 6 plus 6, 12. 12 means 1 plus 2, 3. 3 plus 5, 8. 8 plus 8, 16. 16 means 1 plus 6, 7. 7 plus 6, 13. 13 means 1 plus 3, 4. 9, we don't need to add. The reason behind this, we have 4, then 4 plus 9, 13. 13, 1 plus 3, again 4. So even if we add 9, it doesn't matter. We were at 4, again we are at 4. Then 4 plus 5, 9. So total summation is 9. Since 9 is divisible by 9, hence the summation is divisible by 9 and the number is divisible by 9. So that was for divisibility test of 3 and 9. Now we'll see divisibility test of 11. Again, that is a bit critical. Just take a number 7, 5, 6, 2, 8. That is a 5-digit number. Let us name it. This is the first digit, this is the second digit, this is the third digit, this is fourth digit, and this is fifth digit. So the rule says that the difference between summation of the odd places number and even places number, if it is divisible by 11 or 0, then number is a multiple of 11. So find the summation of digits at odd places. These are 7 plus 6, 13 plus 8, 21. Find the summation of digit at even places. These are 5 and 2, 7. Find the difference between these two. Difference between these two. Maybe this one is bigger and this one is bigger. Doesn't matter. So difference between these two is equal to 14. Since this difference is not a multiple of 11, hence this number is not a multiple of 11. Now have a look on the divisibility test of a composite number like 12. 12 is equal to 3 into 4, 2 into 6. So to check the divisibility of 12, whether we will take 3 into 4 or 2 into 6, we will not take 2 into 6 because these two factors are not co-prime to each other. So we will divide 12 as a multiplication of two of its co-prime factors. So if a number is divisible by 3 and 4, the number has to be divisible by 12. The reason again behind this, that these two factors 3 and 4 are co-prime to each other. Divisibility test of 36 is 9 into 4. 9 into 4 is equal to 36, while these two numbers are co-prime to each other. Hence to check divisibility of 36, we'll check with 9 and 4. In other words, if a number is divisible by 9 and divisible by 4, then number must be divisible by 36.